So what's the best way to add 2, 3, even 400 horsepower to your Shelby GT500? With a Kenne blower upgrade. In this video, we'll cover the limitations of the factory root supercharger on the GT500, both the 5.4 and the 5.8. We'll also cover some of the available upgrades and why it might not be a good idea to step up just a little bit to the next size blower. I mean, if you're going to step up, step all the way up. We'll follow that up with a direct comparison on the blower dyno between the factory roots blower and the Kenne twin screw. Now that blower dyno gives us a ton of good information. The two most important, charge temperature and parasitic loss. Now parasitic loss is the power required to drive the blower. Then we'll finish things up with some design elements that make the Kenne supercharger unique in the industry. Things like a billet case, a 4x6 rotor pack, and liquid cooling. Now we've got a lot to cover, so let's get going. So why upgrade the supercharger on your GT500? Well, the reality is that the supercharger itself is what's limiting the power output. You see, the motor can withstand a lot more power and a lot more boost. So even if you turn that factory blower all the way up, heck, even if you add cylinder heads and camshafts and headers, that factory supercharger is still the limiting factor. The only option is to go bigger. If you're a GT500 owner looking to upgrade your factory supercharger, there are a lot of options, including the 2.65 liter. Now the 2.65 will definitely make more power than the smaller 2.3, and here's why. Positive displacement superchargers work like this. For every revolution, they provide a fixed amount of airflow. If you make the supercharger bigger, every revolution provides more airflow. More airflow equals more power. The question isn't whether the 2.65 makes more than the 2.3, it does. But how much more? I mean, why step up from a 2.3 and jump up 0.35 liters to the 2.65 when you can step up from the 2.3 all the way up to a 3.6 liter? I mean, that's a gain of 1.3 liters. The 3.6 liter Kenne is almost a full liter bigger than the 2.65. And remember, when it comes to positive displacement superchargers, bigger is better. Now that we understand if you want to make big power, you install a big blower, let's take a look at a direct comparison between the factory root supercharger and a Kenne twin screw on the supercharger dyno. So what exactly is a supercharger dyno? Well, it's a dyno designed to isolate the supercharger away from the motor. By running just the supercharger, we find out exactly how well it performs. Now with a supercharger dyno, we can run any combination of RPM, boost, and airflow. Along the way, we find out valuable information like the charge temperature and parasitic loss associated with driving that supercharger. Now it's important to understand the difference between a blower dyno and a blower run stand. The difference between a run stand and a supercharger dyno is dramatic. With a run stand, you have a small electric motor that spins the supercharger up, and that works well to find out if the supercharger works. The problem is, it's not a blower dyno. You see, it takes as much as 300 horsepower or more to spin some of these superchargers at maximum RPM and boost and airflow. And a small little electric motor just isn't going to get that done. That's why Kenne relies on a 500 horsepower LS V8 to run their blowers. Using that motor, they can run any of these blowers at maximum RPM, maximum boost, and maximum airflow. Now that we understand how the supercharger dyno works, we can take a look at that comparison between the factory root supercharger and the Kenne twin screw. Now both superchargers were installed up on the dyno and run at the same airflow and boost level. Run at 20 pounds of boost, the air coming out of the factory supercharger was 55 degrees hotter than the Kenne twin screw. That's right, the air exiting that root supercharger was 335 degrees. So you have your choice. If you're running big boost and big power, what would you rather have? Hotter air or colder air? In addition to monitoring the charge temperature, we also measured the parasitic loss associated with driving both superchargers. Now both blowers were installed up on the blower dyno. Both are run at the same airflow and boost level. Run at 20 pounds of boost, that factory roots blower required 195 horsepower just to spin the supercharger. The Kenne required only 146. That's a savings of 49 horsepower. So what does this mean? Well, in addition to being bigger and being able to support more power, the Kenne Bell also makes an extra 49 horsepower at the same boost and same airflow. Now let's take a look at the design elements that make the Kenne Bell twin screw unique in the industry. First up is the 4x6 rotor pack used by Kenne Bell. Now this 4x6 rotor pack makes the Kenne Bell twin screw not only more efficient than the factory roots blower, but also more efficient than the less effective 3x5 rotor packs used by other twin screws. Improving the efficiency of that 4x6 rotor pack is a billet case. The billet case eliminates the deflection that's inherent in cast cases. I mean, look at some of the factory blowers. They rely on a coating on the rotors to tighten up the tolerances. The problem is, at high RPM and boost levels, that coating can come off and deposits in the intercooler. If the intercooler wasn't there, it'd be in the motor. The final design element is something Kenne Bell calls liquid cooling. Now, liquid cooling was designed to cool the front half of the blower, including the gear oil. If you've never measured the gear oil in your factory roots blower, you should. Run at sustained RPM and boost levels, that gear oil gets hot enough to disintegrate the coupler inside. Not good. Now the Kenne Bell can run much higher RPM and higher boost levels. Liquid cooling allows them to combine that ability with longevity that a roots blower just doesn't have. We've covered a lot in this video, including the bigger is better, the results of the blower dyno, and the design elements. From street to race, only Kenne Bell has you covered. Whether you're looking to reduce the charge temperature and parasitic loss of your street supercharger, or build a fire-breathing monster like Mark Myron's Kenne Bell supercharger module, when we're talking over 1,600 horsepower, as much as 35 pounds of boost. Can the factory blower do that? No. Can the 2.65 do that? No. From street to race, only Kenne Bell covers the whole broad spectrum.